This lecture is all about the landscape and geology of the Grand Canyon. Its main rock units are described, from the ancient bedrock of the inner gorge to more recent landslide and rockfall deposits. But if you really want to learn about the Grand Canyon, try hiking it yourself. Like Bonnie and Ford are doing in this image. They're hiking up Monument Creek from the Colorado River as part of a long loop hike, which proceeded up to the Tonto Trail, over to Hermit Creek, and back down again to the river. Now that was a great hike. Grand Canyon National Park is located in north central and northwestern Arizona. Including Marble Canyon, it stretches almost 300 miles from Lake Powell in the east to Lake Mead in the west. This is a simple location map that shows the various boundaries, towns, cities, and highways in the region. Being familiar with the physiography of an area is extremely important in understanding its geology. This is a color-coded digital elevation map of the Grand Canyon region, where the tan and dark green areas represent lower elevations, and the light green areas represent higher elevations. The Grand Canyon is commonly referred to in terms of eastern and western areas, with the eastern portion being more visited. The Colorado River enters Arizona at the Utah border and flows south before turning west towards Nevada. Lee's Ferry is a historic river crossing site, but is now where most river trips put in. The river flows south through Marble Canyon towards the Little Colorado River, or LCR. It then bends west at Desert View and flows through the Kaibab upwarp into the inner gorge, with the south rim and north rim on either side. The isolated settlement of Phantom Ranch is a trail nexus and destination for avid hikers. Farther west is Havasu Canyon, which, like the LCR, has turquoise blue water, but also large waterfalls. Perched on the rim of the canyon is Vulcan's Throne, a notable cinder cone of the Uinkaret volcanic field. Many river trips end their journey near there. Along with Lee's Ferry, Diamond Creek serves as the only road access to the river in its entire length, and some trips end there too. Finally, the Colorado passes through the Grand Wash Cliffs and into Lake Mead, where river trips can ultimately take out at Pierce Ferry. In most arid regions, the shape of the landscape is a direct reflection of the geology underneath. For example, some rock types like limestone, sandstone, schist, etc., are resistant to weathering and form cliffs. Others, like mudstone, are not as resistant to weathering and tend to form slopes. This is a view of the south rim of the Grand Canyon, where the cliff slope sequence is clearly displayed. This is a geologic timeline of Earth's entire history, from a little over 4.5 billion years ago to the present. The geologic history of the Grand Canyon is largely represented by 3 different ages of rocks: Proterozoic, Paleozoic, and Cenozoic. Together with a package of Paleoproterozoic igneous and metamorphic rocks, the Meso and Neoproterozoic sedimentary and igneous rocks make up the oldest group of units. A series of Paleozoic strata form the bulk of the Grand Canyon sequence, and Cenozoic volcanic and surficial deposits are locally exposed as well. You can see that significant amounts of time are not represented by the Grand Canyon's rocks. Over 2.5 billion years had gone by before the oldest of Grand Canyon's rocks were formed. At 1.84 billion, the Grand Canyon's oldest rocks are truly ancient, but formed nowhere near the beginning of Earth's history. More intervals of missing time are present throughout the Grand Canyon's geologic timeline and are known as unconformities. Looking more closely at the last 500 million years or so, the Phanerozoic eon, we can see that the Grand Canyon sequence of rock layers represents much, but not all of the Paleozoic era, only the earliest portion of the Mesozoic era, and only the latest part of the Cenozoic era. So, When we look into the depths of the Grand Canyon, we can use it to learn about the Earth's past. But just as an old book may have pages or even whole chapters missing, the rocks of the Grand Canyon do not tell a continuous story and only directly represent part of Earth's history. This graphic summarizes Grand Canyon's missing rocks in time. The rock sequence exposed in the Grand Canyon spans a range of about 1,570 million years, from 1840 to 270 MA. After you do all the math, the rock units themselves only represent an estimated 413 million years, whereas rocks representing the other 1,157 million years of geologic time are not present in the Grand Canyon. The boundaries where rock units are missing are called unconformities and represent major amounts of geologic time. Unconformities typically represent periods of uplift and/or tectonic deformation, like tilting and folding, that result in non-deposition, where no sediments or rocks are deposited. It could also represent periods of erosion that erase existing rocks, or both. So when you look at the Grand Canyon, we're talking almost 75% of the geologic time span is missing. Conversely, the rocks you see at the Grand Canyon only represent about 1/4 of its overall geologic history. Yes, the Book of the Grand Canyon is missing a serious amount of pages. The stratigraphy of the Grand Canyon is the study of its rock units, or strata. These dominantly include Proterozoic rocks of different compositions that are overlain by Paleozoic sedimentary rocks. The older Proterozoic rocks are located at the bottom of the canyon, mostly in what's called the inner gorge. These are often referred to as basement rocks. Above this is a thick sequence of mostly flat-lying Paleozoic sedimentary rock, commonly referred to as layer cake. All of these units are described on a detailed stratigraphic column infographic that I put together a few years ago. This puppy took a significant amount of time and research to complete. It's now available from the Arizona Geological Survey as Contributed Report CR21D. Click on the link and check it out. So now let's talk briefly about some of these rock units and get familiar with Grand Canyon stratigraphy. The oldest group of rocks includes metamorphic rocks of the Yavapai Supergroup, sometimes referred to as the Granite Gorge Metamorphic Suite. These are Paleoproterozoic, roughly 1,750 to 1,740 million years in age. These rocks are only exposed in the inner gorge, along the Colorado River and its tributaries. Incredible exposures are present along the Kaibab and Bright Angel trails in the Phantom Ranch area. These are some of my favorite Grand Canyon rocks, as they form the primal, forbidding landscape of the inner gorge. In the Grand Canyon, 3 major units make up the metamorphic basement rock: the Brahma schist and gneiss, the Rama schist and gneiss, and the Vishnu schist. These all can look very similar to each other from a distance, especially when weathered or covered by desert varnish. Looking at metamorphic minerals is typically what is necessary to identify each unit, and even then, these rocks do not give up their secrets easily. As we have learned, metamorphic index minerals can tell us something about the general protolith of a metamorphic rock. In this case, the Brahma's protolith is thought to have been a mafic volcanic rock. The Rama's protolith may have been more of a felsic volcanic rock, whereas the Vishnu's protolith was likely sedimentary in origin. All of these rocks formed within a volcanic island arc setting. A side note, in the Hindu religion, Brahma is the god of creation. The 4-armed Vishnu is considered to be a protector against misfortune and the preserver of the universe. And Rama is a perfect human and 7th avatar of Vishnu. Paleoproterozoic intrusive igneous rocks span a range of ages from 1840 to 1660 MA. These are mostly granitic to dioritic rocks exposed only in the inner gorge along the Colorado River and its tributaries. Fantastic exposures of granitic pegmatite dikes are present along the lower South Kaibab Trail. The oldest intrusive unit, indeed the oldest known rock in Arizona, is the Elves Chasm granodiorite, clocking in with an age of 1840 MA. This rock is older than the Yavapai Supergroup metamorphic rocks and actually forms the basement upon which the Brahma, Rama, and Vishnu were originally deposited. Younger intrusives are much more common and include many different plutons having a range of ages from between 1740 and 1660 MA. These include the Zoroaster granodiorite, Surprise Canyon granite, and a vast number of unnamed granitic pegmatites. Intergorge intrusive rocks are commonly referred to as the Zoroaster granite, but are more accurately subdivided into different plutons based on age, composition, and magmatic origin. By the way, Zoroaster was a philosopher who founded a monotheistic religion around 700 BC that was concentrated on the spirit of good. Light-colored granitic intrusions and granitic pegmatites are ubiquitous in the intergorge. They largely represent the crustal melting and magma movement that occurred deep within a Paleoproterozoic volcanic arc. Here, Paleoproterozoic igneous and metamorphic rocks form the steep and foreboding canyon walls of the inner gorge. This area, between Cottonwood Creek and Vishnu Creek, includes dark-colored metamorphic rocks with ages between 1750 and 1730 MA, and younger, lighter-colored intrusive rocks of the Cottonwood pegmatite complex, with ages of 1685 to 1680 MA. These intrusive rocks are typically light-colored, medium-grained granites, and very coarse-grained granitic pegmatites. These rocks formed by the partial melting of the lower crust that accompanied compressional deformation and metamorphism. This is an early Ron Blakey paleogeographic reconstruction of the Paleoproterozoic of western Laurentia. Subduction-related tectonics dominated this portion of the craton, where various island arcs and microcontinental fragments formed and collided with the older Archean-aged Wyoming craton. The Grand Canyon Supergroup is a sequence dominantly composed of Meso and Neoproterozoic sedimentary rocks, spanning a range of ages from 1254 to 742 MA. Mafic lava flows and sills are also locally present. The supergroup is largely composed of the Unkar and Chuar groups, with the Nankoweap Formation separating the two groups. In most places in the Grand Canyon, the supergroup is absent, and younger Paleozoic strata directly overlie the older igneous and metamorphic basement rocks. But in the eastern Grand Canyon area, the supergroup is locally preserved in fault-related half-graben and can be of significant thickness. Supergroup rocks are typically easy to distinguish, as their distinctive, gently dipping strata contrast nicely with the Paleoproterozoic igneous and metamorphic rocks below, and the relatively flat-lying Paleozoic sedimentary rocks above. The Unkar Group is the older of the supergroup's two groups. It contains 5 fairly distinctive rock formations, all of Mesoproterozoic age, from 1254 to 1104 MA. The oldest Unkar layer is the Bass Limestone, with an age of 1254 to around 1187 MA. And it's a carbonate rock that's locally baked into a marble and bleached white where in proximity to Cardenas Dike sills, like here at Dubendorf Rapids. The Bass contains fossilized stromatolitic domes that represent the dominant life form of the Mesoproterozoic. The overlying Hakatai Shale, with an age of 1187 to 1167 MA, is a distinctively colored reddish slope former that contains mud cracks, ripple marks, etc. These suggest deposition above sea level in floodplains, tidal flats, and other areas. Next is the highly resistant Shinumo Quartzite, with an age of 1167 to around 1140 Ma. And this is a shallow marine unit composed of cross-bedded quartz arenite that forms massive cliffs. The overlying red to brown colored Dox Formation has an age of 1140 to 1104 Ma. This is an extremely thick sedimentary unit interpreted to have a tidal flat or near-shore depositional origin. Finally, the Cardenas Basalt, with an age date of 1104 Ma, is composed of a sequence of basaltic lavas only exposed in the eastern Grand Canyon. Farther west, this unit consists of mafic intrusions, mafic sills and dikes that intrude the older supergroup rocks. The Cardenas erupted or intruded during a time of crustal extension of the supercontinent Rodinia. Except for the Cardenas rocks, these are all sedimentary rocks that do not yield direct isotopic ages. However, their ages can be estimated through analysis of detrital zircons and micas. This is a spectacular example of cross-cutting relations exposed at Hance Rapids, where the brick-red Mesoproterozoic Hakatai Shale is cut by an intrusion of the Cardenas Basalt. Both units are part of the Unkar Group and the larger Grand Canyon Supergroup. This intrusion is classified as a dike since it cuts across the pre-existing sedimentary layering. Note the prominent columnar joining in the dike. These are cooling fractures. The Nankoweap Formation lies in between the Chuar and Unkar groups. Its exact age was always poorly constrained, but new dating has revealed it to be just slightly older than the Chuar, roughly 800 to 770 million years in age. Some are suggesting that it even be included in the Chuar Group. The Chuar Group spans a range of ages from 770 to 742 Ma. It's over 5,000 feet thick and is composed entirely of sedimentary rocks. The mudstone, sandstone, and carbonate rocks of the Galeros and Kwagunt formations were originally deposited in shallow marine shelf and coastal plain environments. The multicolored layers of the Galeros Formation are well exposed in the middle of the Chuar syncline along the carbon lava loop hike. Here is an interpretation of the Mesoproterozoic of western Laurentia, which together with Australia, East Antarctica, and other cratons, form the supercontinent Rodinia. Sedimentary rocks, like those of the Unkar, Apache, and Pahrump groups, were deposited along the cratonic margins. And failed rifting of this supercontinent also produced extension-related mafic volcanics and intrusives. This late Neoproterozoic Paleogeography shows the separation of the Laurentian craton from Australia and East Antarctica during the main rifting of the supercontinent Rodinia. Just previous to this time, Chuar Group and correlative sedimentary sequences were deposited in various environments on the craton and along its margins. Except for those few areas where there are Grand Canyon Supergroup rocks present, the Paleoproterozoic igneous and metamorphic rocks are directly overlain by sedimentary rocks of Paleozoic age. In between these two groups of rocks is what's called the Great Unconformity. Originally observed by John Wesley Powell in 1869, this unconformity represents a massive time interval not represented in the Grand Canyon's rock record. The Great Unconformity is formed by the Cambrian Tapeats Sandstone, where it directly overlies Paleoproterozoic igneous and metamorphic rocks, making it a classic nonconformity. During the intervening time of over 1 billion years, there had to be uplift and erosion to bring the igneous and metamorphic rocks to the surface, where the sand of the Tapeats Sea could then cover it. Unconformity also exists between the gently tilted Grand Canyon Supergroup and the flat-lying Paleozoic section. In this case, the Great Unconformity is an angular unconformity and represents a shorter interval of time. This is a view west from Plateau Point, Here, the Great Unconformity is a nonconformity between the igneous and metamorphic rocks of the inner gorge and the relatively flat-lying Tapeats Sandstone above. The unconformity here spans about 1,200 million years. By the way, Horn Creek Rapid is one of the largest on the Colorado River. Definitely go right in this rapid. Kurt is seen just below the Great Unconformity, here in Blacktail Canyon at River Mile 120. Bedded Arcos of the Cambrian Tapeats Sandstone has an age of 508 to 507 Ma, and it overlies foliated quartz vein-rich Paleoproterozoic rocks of the Brahma schist, which have an age of about 1750 Ma. This yields a nonconformity that represents well over 1 billion years of geologic time. And a shout out to Kurt, a field trip veteran and one of the finest students ever to pass through MCC's geology program. Looking downriver at mile 127 near Spectre Chasm, the Great Unconformity is dramatically exposed where the Cambrian Tapeats Sandstone overlies the black amphibolites of the Paleoproterozoic Rama schist and gneiss. The Rama is roughly 1,200 million years older than the Tapeats. Think about that. So, the Great Unconformity here, as in Blacktail Canyon, represents over 1 billion years of geologic time. Across from Plateau Point, in the area of Cheops Pyramid, is a geologic location informally named Cheops Bay. This is an area where Grand Canyon Supergroup rocks, namely the highly resistant Shinumo Quartzite, formed islands that projected above the surface of the Tapeats Sea during the Cambrian. The area here marked by the Y represents a Shinumo Island that was higher than the surrounding Tapeats Sea, the area marked by the sea. If you try, you can imagine the waves crashing against the quartzite sea cliffs. Eventually, either sea level rose or the land subsided, and the islands were covered by the waters of the Bright Angel Sea, above the dashed line. As an aside, it was ASU professor Paul Knauth who dubbed this area Cheops Bay, and he led many geology students down the South Kaibab Trail back in the day. So here's a view of the Cheops Bay area from Plateau Point, and this is a diagrammatic interpretation overlay of the Cheops Bay area as it may have been during Tapeats time, back in the Middle Cambrian, over 500 million years ago. Let's visit Utah Flats, a vantage point on top of the Cheops Bay Paleo Island. Here, see how both the Tapeats and Bright Angel pinch out against the Shinumo. And note the absence of the Tapeats, where the Bright Angel directly overlies the Shinumo. Cheops Bay, definitely worth visiting on your next vacation to the Cambrian. The third major package of rocks includes the ones that form most of the iconic vistas that we're used to seeing from the Grand Canyon. The Paleozoic sequence is composed entirely of sedimentary rocks. These relatively flat-lying strata, commonly referred to as layer cake, include Cambrian through Permian rocks that form cliffs and slopes of an intricate canyon landscape. At upper left here, we see the view that most visitors get to the Grand Canyon. This is from Mather Point at the South Rim Village, and it's the view looking north towards the North Rim, and you can see the entire Paleozoic sequence from there. Upper right shows a view that most visitors to the canyon do not get, and this is because it's in a remote area of the eastern Grand Canyon along the Little Colorado River, and you either have to be on a river trip or be doing a serious hike to get to this point. And again, here the entire Paleozoic section is exposed from the Little Colorado River and the Tapeats there all the way up to the rim where the Kaibab Formation is exposed. And at bottom is the view from Cape Royal along the North Rim, and this is the view to the south, and it's a tremendous vista there where you can see down through the entire Paleozoic section. The Tonto Group is made up of the oldest Paleozoic rocks in the Grand Canyon area. Through recent stratigraphic and detrital zircon research, it can now be expanded to 5 units, spanning 30 million years of the Cambrian period, from 527 to 497 Ma. These include the Sixtymile Formation, Tapeats Sandstone, Bright Angel Shale, Muav Limestone, and Frenchman Mountain Dolostone. Recent dating of the Sixtymile Formation, once thought to be the youngest Neoproterozoic unit in the Grand Canyon, now make it the stratigraphically lowest and oldest Paleozoic unit. It is only a few local exposures in the eastern Grand Canyon. Before the reassignment of the Sixtymile Formation to the Cambrian, Tapeats Sandstone had always been known as the oldest Paleozoic rock unit in the Grand Canyon. The Tapeats Sandstone is Middle Cambrian in age, now dated fairly precisely at between 508 and 507 Ma, and the oldest portion of the Cambrian Tonto Group. Tapeats typically forms the upper part of the Great Unconformity in most areas of the Grand Canyon. The Tapeats Sandstone is a cliff-forming unit composed dominantly of cross-bedded feldspathic arenite, also known as arkose, with lesser amounts of fine-grained sandstone and mudstone. Trilobite tracks and body fossils are also locally present. The Tapeats Sandstone is a fairly resistant cliff-forming unit that has a distinctively dark brown ledgy appearance. One of the most stunning exposures of the Tapeats is in the Slot Canyon portion of Lower Blacktail Canyon. The Tapeats was originally deposited in a nearshore shallow marine environment on the western margins of the continent of Laurentia, which was just south of the equator at the time. The area on the right there in brown represents the land area of Laurentia. The light blue is the continental shelf around its margins, and the deeper blue on the left is the deeper marine areas of the ocean called Panthalassa. The Bright Angel Shale is the layer directly above the Tapeats Sandstone and is also Middle Cambrian in age, now dated at between 507 and 502 Ma. It's also now the third formation in the Cambrian Tonto Group. Bright Angel is a greenish-gray slope-forming unit composed dominantly of mudstone, with sandstone and dolomite also present. Ripple marks and trilobite trace fossils are abundant as well. It is complexly interbedded with a number of carbonate lenses, which makes its identification in some places problematic and frustrating, to say the least. A typical exposure of the greenish-gray Bright Angel Shale is like the one shown here along the South Kaibab Trail below Skeleton Point. Here is the slope-forming Bright Angel Shale where it's exposed in the 75-mile creek area of the eastern Grand Canyon, and this is just west of Desert View. You can see the Bright Angel there in between the Tapeats beneath it and the Muav above it. The ledgy nature of the upper part of the Bright Angel is due to the interbedded lenses of carbonate, and those are typically dolostone layers that form those small cliffs. The Bright Angel Shale was originally deposited in a shallow marine environment, much like the Tapeats, but likely in somewhat deeper and quieter water. The Muav Limestone overlies the Bright Angel Shale, and like the Bright Angel and Tapeats, is also of Middle Cambrian age, specifically dated at between 502 and 499 Ma. It's the fourth formation in the Cambrian Tonto Group. This unit consists of up to 7 members and thickens significantly to the west. Again, a number of Muav carbonate lenses intertongue with the underlying Bright Angel Shale, making field identification of its lower boundary somewhat problematic. Here's a typical exposure of Muav limestone, as seen along the Bright Angel Trail just above Indian Gardens. The Muav is mostly a cliff-forming unit, composed of well-bedded limestone and dolostone, with lesser mudstone and conglomerate. Trace fossils are abundant. Of hydrologic interest, the Muav is an aquifer just above the impermeable Bright Angel Shale, resulting in several large springs emanating from the Muav throughout the Grand Canyon. Notable examples include Roaring Springs and Thunder River. Like the Tapeats and Bright Angel, the Muav was originally deposited in a shallow marine shelf environment during the Middle Cambrian. Above the Muav is a sequence of very similar, formerly undifferentiated or unclassified dolomites that have now been recognized as the Frenchman Mountain Dolostone, which correlates with similar rocks exposed in the Las Vegas and Death Valley areas. These carbonate rocks are just slightly younger than the Muav and are early late Cambrian in age, dated at 498 to 497 MA. This formation would then be the fifth and youngest of the Cambrian Tonto Group. The lower contact is conformable with the Muav, however the upper contact is a major disconformity that spans as much as 144 million years, from 497 to 353 MA. That stretches from the Cambrian through the Ordovician, Silurian, Devonian, and into the Mississippian period. Like here in Marble Canyon, this hard-to-see disconformity represents almost 150 million years of missing time. Well, it can be a real challenge to tell these carbonate rocks apart from those of the Muav, for sure. And like the Muav, this unit was deposited across a shallow marine continental shelf. Overlying the Muav Limestone and Frenchman Mountain Dolostone is the Temple Butte Formation, which is middle to late Devonian in age, about 385 to 375 MA. Thus, the contact with the underlying Cambrian rocks is a disconformity that represents over two periods of geologic history, from the late Cambrian to the Ordovician, Silurian, and into the early Devonian. That's about 115 million years of missing time. Contact with the overlying Redwall Limestone is also a disconformity, but only spans about 20 million years or so. This is a typical Temple Butte channel in Marble Canyon, exposed between the older Cambrian Frenchman Mountain Dolostone and the younger Mississippian Redwall Limestone. The contacts here represent disconformities, the lower one being about 112 million years, basically between 497 and 385 MA. The upper one's about 22 million MA, 375 to 353. And the one between the Frenchman Mountain Dolomite and the Redwall is the big one, at about 144 million years, spanning 497 to 353 MA. Here's another look at the two early Paleozoic disconformities that bound the Temple Butte Formation. This is along the Bright Angel Trail just above Indian Gardens. All three units here have similar compositions, so they do not look markedly different. The Cambrian carbonate rocks are directly overlain by the Devonian Temple Butte Formation. That's a disconformity since both units are roughly parallel to each other, and it represents about 112 million years. Then the Mississippian Redwall Limestone overlies the Temple Butte in the same way, forming another shorter disconformity, here only about 22 million years or so. Temple Butte is mostly composed of dolostone and sandy dolostone, and can be somewhat difficult to differentiate from similar carbonate units above and below, the Redwall and Muav limestones. In the eastern Grand Canyon, the Temple Butte is exposed in thin lenses locally between the Redwall and the Muav. But to the west, it is a continuous cliff-forming layer. This is a view of the Temple Butte Formation from the Tonto Trail, looking over at the Tower of Set. In this part of the Grand Canyon, it forms a continuous cliff recognizable between the grayish Muav limestone below and the sheer reddish cliffs of the Redwall limestone above. And at lower left there, that's Dr. Ron Hill waiting patiently for me to quit doing geology and start hiking. The Temple Butte Formation was originally deposited in estuary channels in the eastern Grand Canyon, but transitioned to a shallow marine shelf environment in the western Grand Canyon. These areas were part of the western margin of the continent Euramerica, the descendant of Laurentia, and were still located just south of the equator. For various reasons, the Redwall Limestone is another one of my favorite Grand Canyon rock units. Under the veneer of reddish iron oxides lies beautifully layered fossiliferous limestone, dolostone, and chert that hosts countless springs, waterfalls, and caves. But it also represents the biggest, baddest cliff former of the Paleozoic section. And it's commonly a switchback-filled climb along established trails and an impassable barrier when hiking up tributary canyons from the river. The Redwall Limestone is early to middle Mississippian in age, roughly 353 to 335 MA. The Redwall Limestone disconformably overlies both the Temple Butte Formation and Muav Limestone, and its upper contact with both the Surprise Canyon Formation and Supai Group is also a disconformity. Locally, the lens-shaped Surprise Canyon Formation, which has an age of about 326 MA, fills what were estuary channels cut into the top of the Redwall. So it's like the Temple Butte Formation in that regard. Since the youngest Redwall has an age of about 335 million, this disconformity represents about 9 million years of geologic time. This image shows the first exposure of the Redwall Limestone along the Colorado River. It's at mile 23. Here the purplish-red Surprise Canyon Formation unconformably overlies the Redwall. In most places, the reddish rocks of the Supai Group directly overlie the Redwall. The oldest Supai has an age of about 323 MA. So this disconformity spans a similar amount of time, about 12 million years. At right is a view from the Hermit Trail of a massive Redwall cliff section with the Supai Group above. Here is a view of the middle section of the South Kaibab Trail below Skeleton Point. Several switchbacks are necessary to traverse these cliffs, this steep section of trail through the Redwall Limestone, Temple Butte Formation, and Muav Limestone. Just south of the confluence of Nankoweap Creek, the Colorado River flows through the Paleozoic section in what John Wesley Powell considered to be the southern end of Marble Canyon. The Redwall Limestone forms the prominent cliffs of the desert facade, the canyon rim on river left. The view here is downriver to the southeast from the trail to the Nankoweap granaries, about 600 or 700 feet above the river. Note the hiker in silhouette. This area was inhabited between 900 and 1150 AD, and this granary location may have offered some protection from the elements, thus helping to keep its contents dry. Of course, it could have had other purposes, given its great sightlines both up and down the river. This unit includes 4 cliff-forming members composed of fossiliferous limestone, dolostone, and chert. Chert lenses and nodules are common, and the Redwall contains an array of fossils, including brachiopods, crinoids, sponges, coral, etc. Being a fractured-filled cavernous carbonate unit, the Redwall is a major aquifer and includes numerous alcoves, caves, and springs. Cave of Domes, Redwall Cavern, and Grand Canyon caverns are the most noteworthy, with countless smaller, unnamed, and undiscovered openings. Vasey's Paradise is a usually continuously flowing spring in Marble Canyon, and when flowing, Cheops Falls is the highest falls in the Grand Canyon. Of course, Havasu Creek runs through the Redwall, helping to produce beautiful blue-green carbonate-rich water and several major waterfalls, including Havasu Falls. The Redwall Limestone is prominently exposed along the Colorado River in the South Canyon area of Marble Canyon. Several interesting features are worth noting here. One is Vasey's Paradise, a major spring that emerges from the Thunder Springs member of the Redwall. Note the boat for scale. Discharge is continuous, though seasonal, and is fed by groundwater originating up at the Kaibab Plateau. Discharge rates have varied from 1 to 10 CFS, cubic feet per second. 10 CFS is 4,490 gallons per minute, or 6.4 million gallons per day. The springs support maidenhair, watercress, redbud, Apache plume, paintbrush, etc. But beware, this is one of at least 2 places in the Grand Canyon that has poison ivy. Upstream is Stanton's Cave, a typical Redwall grotto that has several hundred feet of passages. Excavated material from this cave includes split-twig figurines dated at about 4,000 years old, Harrington mountain goat remains about 12,000 years old from the end of the last ice age, and driftwood dated at 40,000 years old. A bat gate was built in 1997 and allows bats to pass, but not people. A few historical notes. George W. Vasey was a botanist who served with John Wesley Powell, and Robert Brewster Stanton was chief engineer of an 1889 railroad expedition who stashed his boats and supplies in the cave after 3 men had just drowned upriver. The Redwall Limestone was originally deposited in a shallow marine shelf environment, much like that of the earlier Muav Limestone and Temple Butte Formation. During the Mississippian, this warm, shallow equatorial sea existed across much of Arizona, and much of western Euramerica as well. First mapped in the 1970s, the Surprise Canyon Formation is a newcomer to Grand Canyon stratigraphy. This late Mississippian channel filling unit has a narrow age range from 326 to 325 MA. The Surprise Canyon Formation's lower and upper contacts are disconformities, with it being 9 million years younger than the underlying Redwall, and only 2 million years older than the overlying Supai. The Surprise Canyon's stream and estuary deposits include abundant terrestrial and marine fossils, including Lepidodendron, Calamites, seed ferns, and over 60 species of marine invertebrates. Surprise Canyon Formation sediments filled channels carved by streams and estuaries into the karst-weathered Redwall surface below, probably much the same way the Temple Butte channels cut into the top of the older Cambrian carbonate rocks. The Supai Group is a thick sequence of reddish early Pennsylvanian to early Permian mudstones, sandstones, and minor carbonate rocks. These span a range of ages from 323 to 290 MA. In the eastern Grand Canyon, the Supai is composed of 4 separate rock formations: the Wattahamaji Formation, Manakacha Formation, Wescogami Formation, and Esplanade Sandstone. Other than the Esplanade, most of these are very difficult to tell apart. A 5th formation, the Coconino Limestone, is present in the western Grand Canyon. The reddish rocks of the Supai Group unconformably overlie the Redwall Limestone. The Wattahamaji Formation has an age of about 323 MA, so this disconformity spans about 12 million years. These relations can be seen at Zoroaster Temple and along the Hermit Trail. The Hermit Formation overlies the Esplanade Sandstone. This boundary is locally both conformable and unconformable. Supai Group rocks are well exposed along the South Kaibab Trail. Here, O'Neill Butte is largely formed in the Permian Esplanade Sandstone and is capped by a small remnant of the Permian Hermit Formation. The contacts between the Pennsylvanian Wescogami, Manakacha, and Wattahamaji formations are nondescript and typically hard to identify. The Wescogami contains trace fossil tracks of tetrapods, 4-footed land animals, that were likely primitive reptiles. The trail then descends into the Mississippian Redwall Limestone below Skeleton Point. Historical note: O'Neill Butte is named for Captain William O'Neill of Teddy Roosevelt's Rough Riders, killed in the Spanish-American War. O'Neill once said, "God made the canyon, and John Hance made the trails, neither would be complete without the other. The various formations of the Supai Group were deposited in diverse environments, from shallow marine shelf to tidal flat to river floodplain to coastal sand desert. These sediments were deposited around the margins of the Defiance Zuni uplift, which was related to the ancestral Rockies located farther to the northeast. This region was located along the northwest side of the supercontinent Pangaea. The Hermit Formation is an early Permian, roughly 292 to 284 Ma, slope-forming unit. The contact with the underlying Esplanade sandstone is both conformable and unconformable, whereas the contact with the overlying Coconino Sandstone is disconformable. It's a disconformity. The Hermit Formation is comprised mostly of well-bedded mudstone, we sometimes call red beds, with mud cracks, ripple marks, and plant fossils present locally. Being a slope-forming unit, the Hermit Formation is typically covered by soil, vegetation, and/or debris from overlying units, especially the Coconino Sandstone. But where it's exposed, like this locality in Marble Canyon, you can see its well-developed red-bedded nature. Looking west at Aramita Mesa from the Hermit Trail, the Hermit Formation lies in the middle of the Pen-Perm sequence. It's pretty easy to spot, though. It's the slope-forming unit just below the light-colored Coconino Cliffs. The Hermit Formation represents deposition on arid river deltas and floodplains that were located along the western margin of the supercontinent Pangaea. The Coconino Sandstone is a distinctive, highly cross-bedded, cliff-forming quartz arenite, which is a type of sandstone, that is early Permian in age, roughly 284 to 272 Ma. The contact of the Coconino with the underlying Hermit Formation is unconformable. It's a disconformity. However, the contact with the overlying Toroweap Formation is conformable, no unconformity. So no missing geologic history there. This is the view from Yaqui Point of the Coconino beneath Mather Point along the south rim. Here is the same area as seen from the South Kaibab Trail. The Coconino is the prominent cliff former in the middle of the section. Viewed here from Cape Royal on the north rim, the Coconino Sandstone forms the shoulders of Vishnu Temple, a prominent landmark in the eastern Grand Canyon. Remember that crossbeds are sedimentary structures that represent the slip faces of ancient sand dunes. The Coconino also locally contains trace fossils of both reptiles and insects. This is the view east from Mather Point towards Yaqui Point and Cedar Ridge, where the South Kaibab Trail descends into the canyon. Like the Redwall below, the Coconino is a massive barrier to hikers. Trails are able to pass through only when the rock is broken down, usually by faulting, like here above Cedar Ridge. The South Kaibab Trail enters the image here in the Toroweap, finds its way along the base, and then drops down into the Coconino, where it passes Uaw Point, and then around the corner out of view, and comes back into view down in the Hermit on its way towards Cedar Ridge, down below on the left. Harvey Butchart, NAU professor, famed canyon hiker, and author of 12,000 Miles Through the Grand Canyon, referred to the Grand Canyon geologic map as the fault map, because he used the faults as access pathways to otherwise inaccessible areas in the canyon. The Coconino likely represents an arid coastal sand dune complex on the western margin of the supercontinent Pangaea. The Toroweap Formation is an early Permian 284 to 272 Ma, mostly slope-forming unit composed of sandstone, evaporite, limestone, and dolostone. Here we can see the Toroweap above the Coconino and that view is from the South Kaibab Trail, again looking over at the Mather Point area. Here's the Toroweap below Mather Point, where its three members are well exposed, and they include, from bottom to top, the Seligman member, the Brady Canyon member, and the Woods Ranch member. The Brady Canyon member is a resistant dolostone that forms small cliffs, whereas the other two members form slopes, commonly hosting significant vegetation. As I previously noted, the Toroweap is conformable with the underlying Coconino Sandstone. However, a small disconformity separates it from the overlying Kaibab Formation. This view from Mather Point shows the Toroweap Formation along the upper part of the South Kaibab Trail below Yaqui Point. The Toroweap was originally deposited in several different environments, including open to restricted shallow marine shelf, tidal flats, sabkas, which are essentially arid coastal tidal flats, and coastal sand dunes. This still represents deposition along the northwest margin of Pangaea. The Kaibab Formation is a well-bedded, cliff-forming unit that forms the uppermost layer in the rim of the Grand Canyon. It is Middle Permian in age, 272 to 269 Ma, and is the youngest of the Paleozoic layers. The Kaibab is disconformable with the Toroweap Formation below, but the unconformity does not represent that much time. Where the Triassic Moenkopi overlies the Kaibab, a disconformity of roughly 25 million years exists. The top of the Kaibab is an erosion surface and forms the edge of both the north and south rims. And most younger rocks above it have been entirely eroded away. The Kaibab is composed of two members, the lower Fossil Mountain member and the upper Harrisburg member. The Fossil Mountain member is a well-bedded cliff former composed mostly of carbonates. It forms most of the Kaibab that you see along the rim. Like right here, these well-bedded cliffs are the Fossil Mountain member. The Harrisburg member has a significant amount of evaporites and thus erodes much more easily. It's present at the very top of the sequence you see here. Kaibab contains a whole suite of invertebrate marine fossils, including brachiopods, gastropods, crinoids, sponges, bryozoans, trilobites, you name it. Like the Toroweap, the Kaibab was deposited in several different environments, like open to restricted shallow marine shelf, lagoon, and sabka, which again is an arid tidal flat. Pangaea's western shoreline during Kaibab time was just to the east of the Grand Canyon area. Disconformably overlying the Kaibab Formation are the Moenkopi and Chinle formations. These middle to late Triassic sedimentary units have almost been entirely eroded away in most areas of the Grand Canyon, except for a few localities. One is at Cedar Mountain, just east of Desert View in the eastern Grand Canyon, and another is at Red Butte, just south of the Grand Canyon. Away from the Grand Canyon, these and younger Mesozoic units are widely exposed across much of northern Arizona and southern Utah. In the western Grand Canyon, the late Cenozoic Uinkaret volcanic field includes basaltic flows, cinder cones, and tuff cones. Eruption ages range from Pliocene to Holocene, 3.7 Ma, all the way down to 0.001 Ma. That's like 1,000 years ago. With the Little Spring basalt having a similar age as Sunset Crater in the San Francisco volcanic field to the south. And then there's Vulcan's Throne, with an age of 73 Ka, 73,000 years. This famous cinder cone erupted along the Toroweap Fault, right on the edge of the North Rim. And downriver to the west, you can see unrelated flows cascaded over the rim and down into the gorge. These eruptions occurred both north and south of the canyon, on either side of the river, and many of the lava flows spilled into the gorge, forming lava dams of various heights. The Prospect Dam was the largest and highest of these volcanic dams, and may have created a lake that backed up into the eastern Grand Canyon and even into Utah. Remnants of these flows and dams still locally cling to the canyon walls. By the way, just downriver from Vulcan's Throne are the largest rapids on the Colorado, the appropriately named Lava Falls Rapids. Here's another view of Vulcan's Throne and the lava cascades. And farther downstream, basaltic lava flows fill an old stream canyon just upstream from Whitmore Wash. Must have been a very exciting place to be when these volcanics were erupting. There are countless examples of late Cenozoic mass wasting processes all across the Grand Canyon area. These are represented by various types of surficial deposits, like landslides and rockfalls. Rockfall is a ubiquitous process that is locally represented by cliff scars and talus piles. Boulder Narrows in Marble Canyon is where a big Toroweap block tumbled down from the cliffs right into the middle of the river. If you're lucky, you may experience a rockfall for yourself, from a safe distance, of course. Much greater in scale are the large Pleistocene landslides that occurred in the Grand Canyon, many of which dam the ancient Colorado River. These likely occurred due to periods of wetter climate during the current ice age. Remnants of these epic events are exposed in the Surprise Valley and Nankoweap Mesa areas. Historical note, I've seen rockfalls happen twice. Once along the upper South Kaibab Trail, when a half-meter-sized boulder thundered down the slope, crossed the trail, in between members of our group, and down into a juniper tree below the trail. Oh, that was a close call. The other time was along the river in Marble Canyon. This time we were farther away, and basically just saw a cloud of dust cover the slopes and the river. Several tectonic events have occurred during the Grand Canyon's 2 billion years of geologic history. The oldest event was the Paleoproterozoic Yavapai orogeny, which occurred between 1710 and 1700 MA. This involved subduction-related compression and regional metamorphism. A whole suite of metamorphic and structural features represent this event, including foliation, isoclinal folds, boudinage, etc. These are seen in the Yavapai Supergroup rocks of the inner gorge and in numerous shear zones, including the Vishnu, Bright Angel, Crystal, Bass, Nice Canyon, Separation, etc. The Yavapai orogeny was likely responsible for transforming the sedimentary and volcanic protoliths of the Brahma, Rama, and Vishnu into their present metamorphic rock types. Rifting and breakup of the supercontinent Rodinia, the one that preceded Pangaea, occurred during the Neoproterozoic. This extensional tectonism included normal faulting and tilting. Grand Canyon Supergroup units were tilted and downdrop into graben and half-graben structures. A major fault with Neoproterozoic movement is the Butte Fault, beautifully exposed just above Tanner Rapids in the eastern Grand Canyon. Here it juxtaposes the younger grayish Cardenas Basalt against the older reddish Dox Formation. The lower member of the Nankoweap Formation caps the ridge here. At this point on the Butte Fault, there's an estimated 1,700 feet of west side down Neoproterozoic movement. The late Cretaceous to Paleogene Laramide orogeny occurred between about 80 million to 40 million years ago. It's best known for creating the present-day Rocky Mountains. This tectonic event involved compressional tectonism due to low-angle subduction. In the Grand Canyon area, Laramide tectonism resulted in high-angle reverse faulting and the formation of monoclines. Several large Proterozoic faults were reactivated during this tectonism, including the Butte Fault. Reverse movement along basement faults created these monoclinal folds in the layer cake strata above. In the eastern Grand Canyon area alone, there are several large world-class monoclines, including the Grandview, East Kaibab, and ones at Gray Mountain farther east. A change in the plate tectonic geometry along North America's western margin occurred during the Miocene and continues to this day in some places. the San Andreas transform boundary was established, and crustal extension formed the Basin and Range Province, a wide continental rift. This is informally referred to as the Basin and Range Disturbance. This extensional tectonism was felt in the Grand Canyon area, but only in a limited way in the form of movement along high-angle normal faults, like the Hurricane, Toroweap, and Bright Angel faults. Several of these were large Proterozoic faults that were reactivated during Miocene extension, including the Bright Angel Fault. Bright Angel Canyon largely follows this fault, which Donna is sketching at the 3-mile rest house along the Bright Angel Trail. Indeed, the entire Grand Canyon area was spared significant tectonic deformation for more than the last 500 million years up until the Laramide orogeny. This is witnessed by the number of disconformities in the Phanerozoic rock record, which suggest uplift and erosion, but no real tilting or folding. Even the Laramide's monoclinal folding was mild in comparison to the tectonic activity that occurs in many tectonic mountain belts. The ancient Colorado River and other streams carved out canyon systems of their own. However, it is thought that a through-flowing Colorado River and much of the modern Grand Canyon was formed relatively recently, like in the last 6 million years. This topic has been a controversial one, but it seems likely that regional uplift occurred during the Pliocene and was related to basin and range extension and convection of mantle heat. This uplift transformed meandering stream systems into ones with steep-sided entrenched meanders and slot canyons. This occurred all across the Colorado Plateau region. Examples are numerous and include Antelope Canyon, the goosenecks of the San Juan River, the Little Colorado River Gorge, and of course the Grand Canyon itself, and its vast number of slot canyons and ravines. The Grand Canyon is certainly a special place. Vast, desolate, dangerous, enchanting, beautiful. What a wonderful gift to any student of geology. Well, that's all for now. Till next time.